Not every mathematical fact is obvious just by looking at it. Proof is how you show something is true forever, not just true in the handful of cases you happen to check. A direct proof starts from statements you already know are true, and takes logical steps that each preserve truth. If the starting point is true and every step is valid, the ending point has to be true as well. Let's prove that the sum of two even numbers is always even. Start by writing any even number as 2 times some whole number, so let the first even number be 2 times m, and the second be 2 times n. Now add them together. 2 times m plus 2 times n equals 2 times the quantity m plus n. Since m plus n is just a whole number, this result is 2 times a whole number, which is exactly the definition of even, so the sum of two even numbers must be even, and this holds no matter which even numbers you pick. Here is that same chain of reasoning viewed from a tilted angle. Notice each line still leads directly and only forwards into the next, that forward-only motion is the whole engine of a direct proof. Proof by contradiction works differently, but it is just as solid. You assume the opposite of what you want to prove, and if that assumption leads to something impossible, the assumption must be false, which means the original statement was true all along. Let's use this to prove the square root of 2 is irrational. Assume for contradiction that it can be written as a fraction a divided by b, where this fraction is already in lowest terms. Square both sides. 2 equals a squared divided by b squared, so a squared equals 2 times b squared. That means a squared is even, and if a squared is even then a itself must be even too. So write a as 2 times k for some whole number k. Substitute this back in. 2 times b squared equals 2 times k all squared, which gives 2 times b squared equals 4 times k squared. Divide both sides by 2 and you get b squared equals 2 times k squared, which means b is even too. But wait, we assumed a divided by b was already in lowest terms, meaning a and b share no common factor. We've just shown both a and b are even, so they do share a factor of 2. That is a contradiction, so the original assumption was false, and the square root of 2 must be irrational. Proof by exhaustion checks every single possible case when there are only a small finite number of them. If the statement holds in every case with no exceptions, there is nowhere left for a counterexample to hide, so it is proven for all cases at once. Let's prove that for any whole number, n squared, when divided by 3, always leaves a remainder of 0 or 1, never 2. Since remainders on division by 3 only come in 3 flavors, we only need to check n leaves remainder 0, remainder 1, or remainder 2. Case 1, n leaves remainder 0, so n squared leaves remainder 0. Case 2, n leaves remainder 1, so n squared leaves remainder 1. Case 3, n leaves remainder 2, so n squared leaves remainder 4, which itself leaves remainder 1 when divided by 3. All 3 cases give remainder 0 or 1, so the statement is proven for every whole number. Finally, disproof by counterexample. To disprove a general claim, you only need one single case where it fails, because a universal claim is only as strong as its weakest case. Compare that to proving a claim, where checking one example or 1,000 examples is never quite enough, since there could always be some untested case where it breaks. That asymmetry is the whole point. Disproving is fast, proving is demanding. Let's lock in the full process, in the exact order you perform it. First, decide which proof method fits the claim. Second, for direct proof, start from known truths and move forward step by step. Third, for contradiction, assume the opposite and hunt for an impossible result. Fourth, for exhaustion, list every finite case and check each one. Fifth, for disproof, search for a single case that breaks the claim. Watch out for this common mistake. In a contradiction proof, forgetting to explicitly state what the contradiction is and how it clashes with your assumption leaves the proof incomplete even if your algebra is correct. Here is the simplified version. Direct proof moves forward from known truths. Contradiction assumes the opposite and breaks it. Exhaustion checks every finite case, and one counterexample is always enough to disprove, but never enough to prove.